Okay, so now, up until this point, we focused on one-sided tests for proportions, meaning it was either less than or greater than in your alternative hypothesis. Well, now in a two-sided test, as we've done in section 8.1 and 8.2, now in a two-sided test, this is what your alternative is going to look like. Okay, so when it's not equal to, this is how your standard normal distribution will look like. So here's my standard normal curve. I will find a test statistic, whether it's a negative or positive, it doesn't matter. So here's 0 in the middle. So say that I got a positive z value. Well, yes, I'm going to include what is to the right or outside of that z value. But I also, because it's not equal to, because it's two-sided, I also have to look at the negative z value and what is less than it. These two areas together make up your p-value. The p-value is the sum of both areas. Okay, so be aware of that, the sum of both tails. Okay, now luckily our stats applet has a nice choice that we can do that very easily. Okay, but again, because of symmetry, these z values will be the same, just one's positive, one's negative. All right, so let's take a look here. Example 2, what about a two-sided test? Suppose that you want to perform a test of the null hypothesis p equals 0.3 versus the alternative hypothesis p does not equal 0.3. An SRS of size 50 from the population of interest yields 19 successes. Assume the conditions for carrying out this are met. Calculate the standardized test statistic and find the p-value using technology. So again, this is a two-sided test. So you should make a note of that when you see these hypotheses, right? What kind of sided tests, one or two? So when we're doing the standardized test statistic, that's our z value, we need to find our n. Well, n is just your sample size, 50. We need our null value. The null value is in the hypotheses, that's 0.30. And my sample proportion. And that's going to be 19 out of 50, and that's 0.38. So I will use the formula z equals the sample statistic minus the null value divided by the null value times 1 minus the null value divided by 50, all inside of a square root. Okay, let's go type this away. All right. So if I go here, let's delete that. Okay, so fraction bar, do the top, 0.38 minus 0.30. In the bottom, get your square root down there, open up a fraction, null value, 0.30 times 1 minus 0.30, all over 50. And there's my z value rounded off to 3 decimals. The 4 does not change the 4. So our z equals 1.234. Okay, so now, because it's a two-sided test, watch what I do here. When I go to the stats applet to find the p-value, right, p-value equals. When I go there, okay, normal distribution, calculate area, 0 and 1. Down here where it says calculate the area, I'm going to say outside a region. Outside a region. And we're going to enter the negative z value first and the positive z value second. So our actual z value is 1.234. That's the positive. So then you're also going to input your negative, which is negative 1.234. And this is going to give us this double tail area. And there you go. Okay. So our p-value is going to be 0.2172. And you'll include this picture as well. So if you remember doing this problem in section 8.3, we did this problem using one side. And I think our probability was about 10. Well, now because we're two-sided, we have to include both areas. So a two-sided test actually is going to give you a lot more probability. So to me, I don't know if it's better to say you want to be one-sided, but if you're looking for convincing evidence, I think I would sure like to compare it to one tail than both tails, I think. All right, but okay, here we go. So that's how you do a two-sided test. So now the third objective is going to be doing a 4-step process involving a two-sided test. All right, here comes the fun.